Hello guys, today I'm going to have a very quick review of the Whisper API released by OpenAI. This is the paper behind it. The paper's title is Robust Speech Recognition via Large-Scale Weak Supervision. This is probably the largest supervised trained model for ASR when the paper was published about 4 months ago, which was in the second half year of 2022. This is the model of the proposed work. And you can see that the model is generally a transformer model, which takes in the log spectrum of audio in, and they have the encoder and the decoder, the cross attention. And for those of you who are not familiar with transformer, I have recordings, paper readings on this, and I also have this type of architecture. Is actually for our speech guys, we call this attention-based encoder-decoder architecture. Google guys call this a listen, attend, and spell. I also have a reading on LAS. And you can see for the audio-wise, it's actually from the multitask training data. The audio could be English, the text could be English, and the audio could be Spanish, text could be English. In this case, this is a translation scenario. And also they have the non-English transcription. This is a Korean case, and the no speech scenario. And this is the distribution of their training data. And you can see that almost 2/3 of them is English speech recognition, and about 20% of them is for translation, going from non-English to English. And this is also about 20% of multilingual speech recognition. Okay. About the model again, you can see the encoder part is transformer stacked encoder blocks, and the decoder is also transformer decoder blocks. But what is different than the traditional transformer that is being used in speech recognition is the tokens in the multitask training format. SOT means the start of the sentence, and they have the language token here. So in this English transcription scenario, you may say, okay, do they set this to be English? It does not necessarily have to be, because you can see in their system, they have a language tagging module, which means this language tag is generated by a language identification module. They train on some a language model audio, language audio data. And also transcribe label is also, I don't think you have to have, or this flag, you can definitely infer by the training data, right? You can definitely see if these two things are different, and one of it is English. This is a transcribed flag. The flag could be either 0, 2, or 1. 0 means this is English speech recognition, or non-English speech recognition. And the 1 means translation from non-English to English. And this 0.0 in the green square means some VAD or time-aligned transcription stuff. And you can see in the decoder, they use a autoregressive style of decoding. So the next token predicted is based on, for example, the word brown is based on the past decoded results, which is pretty standard. Talking about the model size, the model size of the Whisper model in this published paper is 1.5 billion parameters. You may ask why this is significantly smaller than their GPT-3 model, which is 175 billion parameters. This is have the consideration of a computational cost, because speech is different than NLP. For every seconds of speech has 100 frames of data, but for the NLP, for each utterance, it mostly just have thousands of tokens. But for the speech, you can definitely have thousands or dozens of thousands of tokens. Definitely, this is not largest model up to now, because about 2.5 years ago, Google trained a big SSL. The largest model that Google had was 8 billion parameters. Regarding the English speech recognition, the media report of OpenAI or the public relation report by themselves, they claim that they have a 5% or less than 5% word error rate on English speech recognition. This is why I think they want people to try their APIs, especially for the English speech recognition. And you can see that the number they're talking about is actually referred in the table number 2. It's on the FLIR dataset. You can see in Whisper Large, they get 4.6. This is what they're talking about, less than 5%. But the issue is FLIR dataset English is read speech recorded in a clean environment, and in a close talking environment, and it does not cover the various cases. What do I mean by cases of the ASR usage? Let's look at this. So there are, I think, in my personal opinion, or it's also acknowledged by most of the speech researchers, speech recognition is facing 3 problems that are hard to resolve. First is the speaker variability, the accent. For example, I'm an immigrant, I have accent, and also for different languages, they have the special accent of that language. For example, dialect, okay? And also speaking style. The FLIR dataset I would just talk about is the read speech. It's just read the text, but sometimes you listen to TED Talk, those guys are having the improvised speech. And also during the dialogue, people have spontaneous speech, which also more difficult than recognizing the read speech. And also the channel variability is the second problem. So FLIR dataset is called a wideband speech recognition. It's recorded probably higher than 16 kilohertz sampling rate. But for the telephony channel, the sampling rate is only 8 kilohertz. Lots of information from the speech is discarded by the telephony company. So this creates difficulty for speech recognition. And also, FLIR dataset is close talking, but suppose you're playing games and you're talking to your TV or talking to your Alexa. This is far field speech recognition. You're away from the microphone. Then you can signal to noise ratio drop and also make the speech recognition more difficult. Also, the noise. Noise is probably the most unresolved issue in the speech recognition nowadays, especially for the acoustic modeling people, because you can have an additive noise. For example, you probably won't be able to hear the office noise in my recording scenario. But if I record this video in a subway, I have a lot of background noise. That's additive noise. And for this room, if this is a really large room, doesn't have any furniture, I can have echo, okay? And suppose I talk over the telephone channel, I can also have some convolutional noise introduced by the switch. This all introduced the difficulty for speech recognition. And talking about the content, or this refers to the third problems that speech recognition is facing, and it's facing more and more because people's lives are quickly enhanced by the new technologies. So this creates many new scenarios every day. So suppose you optimize your speech recognizer on scientific research or paper reading, that speech recognizer will not work for sports comment at all. So that means you have to do something for the language modeling in current scenario. And you can see that for the Whisper model, they do not do language modeling. But usually for the speech API, they would do something called speech modeling. They have a shadow fusion or rescoring on a decoded result to achieve better result. And you may ask, why Whisper AI can get very much better result compared to the published work, okay? Let me tell you, the Wave2Vec 2.0, I also have a paper reading on Wave2Vec, is a fine-tuned model on the Libre speech. And the authors are using this fine-tuned model for other distribution shifted data sets. For example, Libre speech is a red speech data set, but the switchboard data set is a spontaneous dialogue data set and the telephony channel going from wideband to narrowband. So you can see the scenario or distribution has been shifted a lot, but these models are not fine-tuned on this specific task. So they sucks. But from the other end, the Whisper model can perform zero-shot learning. So that means the model is more like a generic model, something like AGI, artificial general intelligence. So it does not suffer much from distribution shift or domain shift. But I would say that if you look at the switchboard results 13.1, that's very, very behind the state of art of fine-tuned switchboard task, which is about 5%, almost as good as human being. Okay. And I want to show you this. And also they have compared the Whisper model with different companies' API. They compared with the company A, B, and C. This is my guess, may not be right. Must have Amazon's AWS speech API and the Google Cloud speech API. And they probably have the Microsoft API or IBM Nuance API. IBM Nuance has been merged in the speech recognition technology, and also Nuance has been acquired by the Microsoft. So these three things might be the same thing. But the point they want to make here is that their model is better than the production model of different other companies. But I have an argument here. You should not compare your research trained model with their production model, because for the production model, people usually want to size that down the model for the cost reason. Because suppose the model is very large, then you serve the model, then the cost per call is high. You cannot make money. And also, you also want to make sure that the server model doesn't blow up the memory of your GPU, right? And also, the model, when the model is very large, even that you say I have enough amount of money to get a better GPU, that means that the speech recognition speed is slow. This is called a real-time factor. So given 1 second of speech, how fast you can finish the speech recognition. So usually the RTF is supposed to be like 0.1 or 0.2, but definitely I think I've seen some reports. They're open source model. They have a very, very high RTF, which is not shown in this table, which this table only shows the WER. So RTF, a very, very important factor to be considered in the real production system, has not been mentioned here. And also, one of my LinkedIn friends mentioned that this is indeed not the best NVIDIA STT model. The best STT model is like XS large or something. It's not the CTC model. CTC model is usually worse than the conformer model people are training right now. And they also have tried to say that this is a better or almost as good as human beings transcription. But like I mentioned before, this does not stand very much to me. Okay, I will stop here. If you have any comments or questions, please comment below. And if you like our channel, please hit subscribe or share the video with your friend. Thank you.